The larger cylinder shown below holds 7 smaller identical solid cylinders inside. So 7, right? Altogether there's 7. 2, 3, 4, 5, 6, 7. All 8 cylinders, right? How does it become 8? Well, you've got one big cylinder and 7 small cylinders. These all have the same height. Let's just call it H. Right, H for height. Right, next paragraph. Given that the radius of each smaller cylinder is r centimeters, so let's say from the center to there, that's r, all right? Each one, right, each cylinder, each of those smaller cylinders have got a radius. There's the radius from the center to the edge. We'll call it r, well that's what they've called it, r centimeters. And obviously the height, I use h. Show that 7 ninths, if you like, 7 ninths of the capacity of the large cylinder is occupied by the smaller cylinders. What I'm going to do is I'm going to work out the volume of one little cylinder. Right, obviously this is a prism, so the cross-sectional area, this bit there, the cross-sectional area, it's a circle, so it's going to be pi r squared multiplied by the length of the prism, or the length of the cylinder, is h. That represents, this thing here, this formula here represents the volume of the smaller cylinder. But we've got 7 small cylinders, so the total volume of all 7 cylinders is going to be 7 lots of pi r squared h. Right, remember, that represents total volume of 7 cylinders. Now what I want to do is work out the volume of the larger cylinder. Remember, from here to here, we represent it as r. Obviously from here to here, that's another r. From here to here, that's another r. Right. So if you think about it, if you focus on the large cylinder, got the large cylinder over here, its center is right there. And that blue line that I've just drawn there, that blue line there represents the radius, which is from the center to the very edge. That represents the radius of the big cylinder. Radius of the big cylinder is clearly not 1r, but it's actually 1, 2, 3r. So the radius of the big cylinder, so we're talking about the big cylinder here, radius is 3r, 3 lots of r, all right? So the volume of this big cylinder, okay, if you think about the cross-sectional area over here, we've got a circle, haven't we? That's a circle. It's pi times radius squared. So the area of that circle is pi times radius squared. Pi times radius, but the radius I've just said is 3r. So it's going to be 3r squared. So that's pi radius squared. And obviously the length of the prism is also h. So that represents the volume of big cylinder. Now I want to know what this is as a fraction of this. So I'm going to represent these two expressions as a fraction. So that will be 7 pi r squared h. That's the total volume of all 7 cylinders, out of the volume of the larger cylinder. That's going to be pi, that pi there, right, 3 squared is 9, r squared is just r squared, and you just got the h. Right, this will simplify look, the pi's cancel. There's a pi at the top, there's a pi at the bottom. These cancel. There's an r squared at the top. There's an r squared at the bottom. These cancel. Right, there's a matching h and h. These cancel. So what are you just left with? You're just left with 7/9. 7/9. Right, so I shouldn't be saying that half of the big cylinder is occupied by the smaller cylinders. It's not half, is it? That'd just be a guesstimate. It's actually 7/9. 7/9 of the big cylinder is occupied by the smaller cylinders, and the rest, so there's 2/9. The rest of it, 2/9, is occupied by just blank space. Okay, just empty space. So really, I've just answered the question here. I had to prove it's 7/9, and I've done it right here.